India has set history with the Chandrayaan-3 mission with a 615 crore rupee budget for a soft landing on the moon's unexplored South Pole region. Let's know how in this video. So guys, I am a space enthusiast and I love to share the India's space journey and scientific contributions with you all. This is Chiru welcomes you all to Learnwithchiru channel. If you want to watch more interesting educational content in a much simplified way in a detailed manner, please subscribe or follow this channel. In this part 1 video, we will learn about the basic information of Chandrayaan-3 mission. First one, its background about the launch vehicle and its objectives, its design, its payloads, and all other information I will discuss it in other part. Now let's jump into the video. What is Chandrayaan-3 mission? Chandrayaan-3 mission is a part of India's ambitious space program and it is the third and most recent lunar exploration mission in the Chandrayaan series after Chandrayaan-1 and Chandrayaan-2. It consists of lander named Vikram and a rover called Pragyan, similar to Chandrayaan-2, but does not have any orbiter. Its proportional module behaves like a communication relay satellite, which means that satellite can be used as a component of a communication system to relay signals from one point or near the Earth's surface to another. The propulsion module carries the lander and rover configuration until the spacecraft is in 100 km lunar orbit. The launch of Chandrayaan-3 took place on 14th July 23 at 2:35 p.m. from the second launch pad of SDSC from Sriharikota. The lander and the rover are expected to land near the lunar South Pole region on 23rd August 23. Have you had any question that why only the lunar South Pole was chosen, why not the North or any other region? Because the lunar South Pole region holds a particular interest of scientific exploration due to their studies that show large amount of ice there. Mountain terrain and unpredictable lightning conditions not only protect the ice from melting but also the landing scientific probes also taking it challenging tasks. Now we are going to learn about the launch vehicle, that is also called as rocket, which has placed our Chandrayaan-3 on a correct orbit. The mission will be launched using a GSLV Mark III rocket, which is the most powerful rocket developed by our ISRO. The rocket has a payload capacity of up to 8,000 kg and is capable of launching heavy satellites into orbit. The rocket's powerful engines will ensure that the Chandrayaan-3 spacecraft reaches the moon orbit with high accuracy and precision. The GSLV Mark III rocket, also renamed as LVM3, which means Launch Vehicle Mark III. The full form of GSLV is Geosynchronous Satellite Launch Vehicle. This LVM3 is a 3-staged medium lift launch vehicle which was developed by the Indian Space Research Organization, primarily designed to launch communication satellites into the geostationary orbit. LVM3 has a higher payload capacity than its predecessor, that is PSLV. PSLV full form is Polar Satellite Launch Vehicle. LVM3 is an operational heavy lift launch vehicle of ISRO, has a spectacular pedigree of completing 6 consecutive successful missions. This is a 4th operational flight of LVM3, aims to launch the Chandrayaan-3 spacecraft to the geo transfer orbit, that is also called as GTO. LVM3 has proved its versatility to undertake most complex missions like injecting multi-satellites, mission planning to ensure safe relative distance among separated satellites through reorientation and velocity addition maneuvers. India's largest and heaviest launch vehicle ferrying India and international customers satellite. LVM3-M4 will be launched from the second launch pad SLP in HDSC Sharikota. Now we will know about the objectives of this mission. ISRO's mission's objective for the Chandrayaan-3 were 1. Getting a lander to land safely and softly on the surface of the moon. Next, observing and demonstrating the rover's driving capabilities on the moon. Third one is conducting and observing experiments on the materials available on the lunar surface to better understand the composition of the moon. Now we will discuss about the spacecraft, which means design of the Chandrayaan-3. Chandrayaan-3 consists of an indigenous lander module, a propulsional module, and a rover to develop and demonstrate new technologies required for interplanetary missions. The lander will have the capability to soft land at the specified lunar site and deploy the rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of a propulsion module is to carry the lander module from the launch vehicle injection till final lunar 100 km circular polar orbit and separate the lander module from the propulsion module. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post separation of lander module. The launcher identified for the Chandrayaan-3 is GSLV Mark III, which will place the integrated module in a elliptical parking orbit (EPO) of size of approximately 170 into 36,500 kilometers. Chandrayaan-3 comprises three main components. One is propulsion module, another one is lander module, and one is rover. Now we will talk about propulsion module. The propulsion module carries the lander and the rover configuration to a 100 km lunar orbit. It is a box-like structure with a large solar panel mounted on one side and a cylindrical mounting structure for the lander, the intermodular adapter cone on the top. Now we will discuss about lander, that is the Vikram. Lander is responsible for the soft landing on the moon. It also box shaped with 4 landing legs and 4 landing thrusters capable of producing 800 newtons. Newton is a unit of force, which will be calculated how much the force is generating through these thrusters. And these 800 newtons, which will be produced by each of the thrusters present in the lander. It carries the rover and various scientific instruments to perform on-site analysis. The lander for Chandrayaan-3 has 4 variable thrust engines with the slew rate, that is changing capabilities, unlike Chandrayaan-2's lander, which have 5, with the 5th one being centrally mounted and capable only of fixed thrust. Additionally, the Chandrayaan-3 lander is equipped with a laser Doppler velocimeter, that is LDV, to allow the measuring attitude in 3 directions. The impact legs has been made stronger compared to Chandrayaan-2. And instrumentation redundancy has been improved. It will target a more precise 4 km by 4 km landing region based on the images previously provided by the orbiter high resolution camera, which is also known as OHRC, that is in onboard Chandrayaan-2's orbiter. ISRO improvised that structural rigidity, increased polling in instruments, increased data frequency and transmission, and added additional multiple contingency systems to improve lander survivability in the event of failure during descent and landing. Now we will talk about the rover, the Pragyan. Pragyan rover is a 6-wheel vehicle with a mass of 26 kilograms, that is also 57 pounds. It is 917 millimeters, that is 3 feet into 750 millimeters, that is 2.46 feet into 397 millimeters, that is 1.302. The rover is expected to take multiple measurements to support the research into the composition of the lunar surface, the presence of water, ice in the lunar soil, the history of a lunar impacts, and the evolution of a moon's atmosphere. Now we will talk about the payloads. Those who don't know about the payloads, I'll explain. Listen. Payloads are the object or entity which is being carried by an aircraft or a spacecraft or a launch vehicle. Sometimes these payloads referred as the carrying capacity of spacecraft. So here in the Chandrayaan-3 there are two types of payloads. These are very important. One is lander payloads and second one is rover payloads. Now we will talk about the lander payloads. In the lander payloads there are 4 payloads. First payload is Chandra Surface Thermophysical Experiment, CHAST. Its function is to measure the thermal conductivity and temperature on the lunar surface. The second one is Instrument for Lunar Seismic Activity, also called as ILSA, for measuring the seismicity around the landing site, which means they measure moon waves around the landing site. The third one is Langmuir Probe, LP. It is used to estimate the plasma density and its variations. Fourth one, a passive laser retroreflector array from NASA is accommodated for lunar laser ranging studies. Basically, it will eject laser beams to study the atmosphere of the moon. Now we will talk about the rover payloads. In the rover payloads, there are 2 payloads. Let's talk about them. The first one is Alpha Particle X-ray Spectrometer, that is APXS. It will derive the chemical composition and infer the mineralogical composition of the lunar surface. The second one is Laser Induced Breakdown Spectroscope, LIBS. LIBS will determine the elemental composition, that is magnesium, aluminum, silicon, potassium, calcium, titanium and iron of lunar soil and rocks around the lunar landing site. Now we will talk about the payloads of propulsion module. The first one is spectropolarimetry of habitable planet Earth shape. It will study the spectral and polarimetric measurement of Earth's from the lunar orbit in the near infrared NIR wavelength ranges from 1 to 1.7 micrometers. Okay guys, the length of the video is already long, so we will continue this in next part that I will release soon. Hey guys, thank you so much for watching till the end. If you love the video, please press the like button for more interesting educational videos. Subscribe to my channel